Here we go. Grade 11s, we've started these. We're solving radical equations. So we'll go back to grade 10 for a moment and we'll just look at a couple equations that we solved that don't involve radicals. Many of the same strategies will apply. So something like this, I like to move whatever side has the least number of x's over. So we'll subtract 13x from both sides. And what do we get? We'll get 4x equals 32. Divide by 4, you get x equal 8. Do you need to verify your solution?
I mean, you should.
Yeah, generally you should. With radical equations, you'll always want to, because there's always a risk of getting values that don't actually work.
How would you cheat on like a test in university though?
Okay, let's keep going. We're going to multiply both sides by 4 on this one. That was just a blatant attempt to get me off track.
Yeah, I'm also curious though.
Yeah,
So.
well, we can talk about it after. 6 times 4 is 24. Should I just divide both sides by 3? You got two options. You can distribute this into the brackets, but because it's multiplying everything and 24 is divisible by 3, I think, I would just divide both sides by 3. It'll make your life a little bit easier. So that's like 8, and then you can add 5 to both sides, so you get 13. Alright. What else? Ooh, an inequality. Right, so there might be some inequalities today, I can't remember. So we'll just subtract 7 from both sides and get x less than negative 2. And remember, this is a range of values. So give me like 2 possible solutions if x is less than negative 2. Yeah, so it could be, x is negative 3. As long as it's less than negative 2, it's a solution. So would negative 10 be an answer? Yeah, and you can always double check, like you plug in negative 10 and make sure that that statement is true. So, negative 3 is less than 5. Yeah. Sometimes they ask that in grade 12 pre-calc or in grade 11. They're like, well, you got this answer, so tell me a couple solutions, and people blank. I don't know why. Right. Here's another one. Let's see. Let's do it this way, so we make sure we review something. I'm going to subtract 5y from both sides. So that would give us negative 2y less than or equal to negative 9. So I'm going to divide both sides by negative 2. Do you guys remember what needs to happen to the inequality sign? Very good. Yeah, if you divide or multiply by a negative number, you got to flip the sign. So there we go. So you get y greater than or equal to 9 over 2. You could have, yeah. Maybe I'll take a quick moment. If I had done it another way, I would still have to flip the sign. So let me show you. So if I just subtracted 3y from both sides, then what will I get on the left-hand side? 0 less than or equal to 2y minus 9. I would add 9 to both sides. Now I'm going to divide by positive 2 this time. So you get 9 over 2 is less than or equal to y. But we don't like to state our solution like that. Right? Like, are these equivalent solutions? Yeah. If your variable's over here, you have to read it going to the left. So this is y greater than or equal to that. So generally, we like to have the variable on the left, and we write y greater than or equal to 9 over 2. So you still end up flipping the sign, even if you don't get the negative. Okay? You would not be done if you got that far. You got to write it like this. It's just like a convention. Everybody agreed. Wouldn't it be nice? Okay? So, what have we got with radicals? Let's see. Consider this equation. So if you look at the permissible values, 5x has to be greater than or equal to 0. So that means your x value, when you divide both sides by 5, has to be greater than or equal to 0. We need to isolate x. So the strategy, generally, so you want to undo the square root. The strategy is, isolate square root. Okay? Try to get it by itself on one side. Right? So if it's a monomial and you square it, then you just get rid of the square root. You also introduce extraneous solutions because now my x isn't under the radical sign anymore, so there's a possibility of getting solutions that don't actually work. So when you get to the end, you need to verify. Okay, so one thing you can do is look at your permissible values. Like that'll tell you, like, is x equal to 20 inside my permissible values?
Yes.
Yeah, it's greater than 0. You still want to check and make sure that the left-hand side equals the right-hand side. So you go back to the original equation, which is this. You plug in 20, make sure that everything works. It seems like it does.
Which can you go up a little?
Yeah, for sure. like that. Okay, so basically what we'll do today is we'll look at a couple different kinds of questions. There's one particular question where, well, I'll point it out when we get there. You need to be a little sneaky when you have a radical involved, so we'll see it. Any questions before we do some examples? And then we're almost done this massive unit. Okay, so single radical equations where you just have a radical maybe on one side and it's probably a monomial. Well that's a lie. Here's a binomial. But anyways, so just one radical. So in this case, I have this isolated. I could square both sides, but it would be better just to get the radical all by itself. So I'm going to divide both sides by 3. Okay, now I'm okay to square both sides. So I can square that, I can square this. So I'm going to get x equals 5 squared is 25, 3 squared is 9. And then let's verify. So when you go plug into the original equation, how do you deal with the square root of 25 over 9?
It's just the square root.
Yeah, it's the square root of the top divided by the square root of the bottom. So you get 5 over 3 times 3 is what? 5, perfect. So the left-hand side equals the right-hand side, so you can just write equals right-hand side. You're good to go. I didn't do my permissible values, but x would have to be greater than or equal to 0. It's just something to keep in the back of your mind. Right, so I get my answer, and I'm like, oh, I seem okay, I'll go verify. This question. So I got this big box. It says isolate the radical, then square both sides. So what would happen if you just squared this? Is that going to make my life easier or harder? Way harder, because you're squaring a binomial. So you're going to get all these cross terms, and you're actually not going to get rid of your radical. You'll probably introduce more radicals to the equation. So that doesn't work. That's why you need to isolate the radical, get it all by itself. So what do I need to move first? Very good, the 5. So we'll add 5 to both sides. So we'll get 4 square root x plus 1 equals 5 plus 3, 8. You could keep this here because it's just multiplying the radical, but if possible, like if it divides evenly, or even if it doesn't, right? Well, on this question I didn't. It's just nice to get all the numbers over there. I'm going to recopy that. 8 divided by 4 is 2. Now I have this all by itself. So if I were to square this side, it's just a monomial. And it's just going to get rid of the radical sign. So you always get the radicand out. So you get x plus 1 equal 4. You can subtract 1 from both sides. You get x equal 3. What would be your permissible values here? So it's this quantity that has to be greater than or equal to 0. So that's why we're solving inequalities before. So you always take the radicand out, and you set it greater than or equal to 0, and then you solve, so x has to be greater than or equal to -1. Do you agree? Yes. Because this is the value that would get you 0. Anything higher would get you bigger numbers. So some people just sort of look at it and they're like, well, if that was -1 or bigger, I would get 0 or higher. Okay? But I recommend just solve the equation so you don't make any mistakes. So should this answer be okay? It should be. Let's check. So right-hand side, left-hand side. So left-hand side is 3. Here I'm going to plug in square root of 3 plus 1, subtract 5. Usually we just do a line. So let's see, that's the square root of 4, which is 2, times 4, which is 8, subtract 5 is 3. Yeah? Agree? Hooray! Okay. There are 2 identical questions with just different numbers. I will give you the solutions if you ever want to go through your notes and do a couple extra. So for A, I got x equal 9 over 16. And for B, 99. Wayne Gretzky's number, the great one. Does anyone talk about Wayne Gretzky anymore? Who? Cody? He's old?
He's out in Holland.
Oh, he's in Holland, yeah. He lives there now, doesn't he?
He's in Oklahoma.
Oh, Oklahoma, yeah, Oklahoma, yeah. I saw pictures of his house. Looks nice. No. That's it. That's all I got. That's all I got on Wayne Gretzky. Okay,
No, can we call it for 30 seconds?
so not all radical equations have real roots. So let's solve this one for a moment. Let's just find our permissible values first. So we take the 2x minus 1, set it greater than or equal to 0. What do we get? Add 1. Divide by 2. It's going to go over here. So x got to be greater than or equal to a half. Now let's isolate the square root. So we'll subtract 5 from both sides. So when I subtract 5, and subtract 5, 2, subtract 5 is negative 3. So what do you guys think? Does that seem to make sense? Can a square root, I should say, equal a negative number? Never. Okay, so you might not notice it here, but right here you could stop and say no solutions. Right? Square root cannot equal a negative number. So you'd be expected to say y. If you're going to say no solutions, you need to say y. Square root cannot equal a negative number. Let's say you didn't notice and you just kept going. Let's see what happens. So I'll just give you a moment.
Backslash for a second?
Can I backslash?
Oh, never mind, my bad.
Okay.
Yeah, that is indeed wrong. That is whoops.
Okay, if you don't notice and you start squaring both sides, okay, so you'll get positive 9, you'll get 2x minus 1, you'll add 1 to both sides, and you'll get x equal 5, which looks good, right? Does it satisfy our permissible value?
No.
Yeah, it's bigger than a half, but when you go verify, it won't work. So that's why it's important to verify, because if you miss something, at least when you go verify and plug in positive 5. Let's see, the original equation you get 10 minus 1, which is the square root of 9. And that's 8, right? 3 plus 5. So 8 is not equal to 2, so it's wrong. So there's no solutions. It would be better if you noticed it right here, because then you don't do all that work. But it's not the end of the world if you do. Yes, sir?
Why can't the root equal a negative?
Well, it's a square root. Square roots can't equal a negative number.
Yeah. Why not?
Well, because it represents the side length of a square, right? So if I say, hey, I got an area of 100, like when I do the square root of the area, it's giving me the side length of the square, which is 10, right? So what does it mean if, like I get that negative 10 times negative 10 is 100, but what does it mean to have a side length of negative 10? So we call that the non-principal square root, and we say it can't equal a negative number. Right? Although we also sometimes say, hey, the square root of 100 is plus or minus 10. But in the context of an equation, it doesn't make sense. Yeah, it's a good question. It's kind of, it always confused me too, like why?
So in square roots given by the question, you can't have a negative number.
Yeah, sure. Like generally we'll take the principal square root, which is just the positive version of the answer. Yeah, in some applications the negative might have a meaning. Like in physics, negatives often just indicate like direction. Like up, down, left, right, whatever. Yeah. So in physics, negatives sometimes do have a meaning. Yeah. Alright. If you guys want to make physics easy, take like AP, take up to grade 12 pre-calc before you take grade 12 physics, and it'll be way easier.
Oh.
Because you learn all the math. You'll learn all the math. And if you're taking the AP physics, take AP calc first, if you can. I don't know. Okay, solving equations with two radicals. Woo, let's see what happens. If possible, there's two things that you can do. If possible, group like terms. So I'm going to say group like radicals. Then isolate. Then isolate on one side. That's one strategy that can work. If that doesn't work, like you got two, like are these like terms? Yeah, so in this case, we'll move it over to one side and we'll basically get rid of having two radicals. But sometimes they're not like terms. If that's the case, you need to move them to either side. You need to move one radical on one side and one on the other and hope for the best. Okay, so if no like terms, so if there's no like terms and you have two radicals, so I shouldn't say like terms, I'm going to say like radicals because I'm specifically talking about the radicals. So if there's no like radicals, if there's no like radicals, move one radical to each side, then solve. So those are some pretty general instructions. So this is an example of situation 1. So if you want to write situation 1. You guys ever watch Jersey Shore? Like the situation? No? No, too old. Okay. That guy just got out of jail, which you guys don't know. You guys seriously have never heard of Jersey Shore though?
I have heard of it.
It was like a show about a bunch of like half Italian New Jersey people. Like it was like one of the first reality shows. Okay. And it's just like them like living their lives, and they were just ridiculous. And there was this guy who had like an incredible six-pack, and he would call himself the Situation. He'd be like, "Oh, yo, the Situation's here!" And like zoom in on his six-pack all the time. He was just, he went to jail after the show. Anyways.
Did you just walk around?
Oh yeah, basically.
What if it was like winter?
Oh, well, it's New Jersey. Does it ever get very cold? Okay, let's solve. Here we go. We are subtracting 2 square root x from both sides. Okay, so then you're gonna get 3 subtract 2, so you just get square root x. And I guess I'll recopy everything else. So this one's gone. Is that okay? And then you can add 4 to both sides. So now you can square both sides and you're happy. So that's like the ones we already did. We should verify. So if you plug in 25, you get 3. So I'll just write verify. I'll do a really quick verify. You would get 3 times 5, subtract 4, equals 2 times square root 25, which is 5, plus 1. So that's 15 minus 4 is 11. That's 10 plus 1, 11. Good? All right. Now there's another one that's identical. I don't think we need to do it, but if you want, like it's literally different numbers, but you would follow the exact same procedure. I actually recommend that you go home and try it yourself. Or maybe after the notes, but you should get x equal 4. Can someone say my... Oh, oh sorry. So this one's x equal 4. Like a good habit to get into with the notes is if there are try it yourselves that we don't do, immediately after the notes, like in those last like 10 minutes of class, like do those questions. Because then that's forcing you to be like, hey, did I get all the different question types? Those are the small like study habits that really make a difference in university. One of the things I had to do was I had to start studying every day. Because you could no longer afford to just kind of, joke your way through the class. It was like if you didn't get the previous lesson, you were done on the next one. And so you just needed to like chip away at it constantly. It's also less stressful because you feel like you're more prepared. Anyway, I'm in a mood. Okay, show this as an extraneous root. Well, one way of showing it would be simply solving it and then just plugging it in and verifying and seeing that it doesn't work. But this is one of those second question types. Remember I said, well, if you have radicals that aren't like terms, make sure that you move one to each side. So are these like terms in any way? No, they're not. So you move one to either side, and then you square both sides. Right? If you were to have them both on the same side, you're squaring a binomial. It's going to be a nightmare. You're going to get more radicals. But if you square this, you get x minus 1. You square this, you just get 2x plus 3. And now that's easy enough. You can solve. So I'm going to subtract x on this side and on this side. So I get negative 1 equals x plus 3. And then I'll subtract 3. Then I'll subtract 3. I get negative 4 equals x. Which seems okay. I didn't do any of my permissible values.
So in this situation, would you want to rephrase it to x equals negative 4?
No, you don't have to. In inequality, yes. For something like that, you don't need to write it like that. It's a good question. Okay, so 2 options. Plug it in and show that it doesn't work. Or maybe you could show that maybe it doesn't satisfy one of the permissible values. So this one needs to be greater than or equal to 1. So would negative 4 work in there? Nope. So no solution. You don't even need to check the other one. You need to show, well, I can't plug negative 4 in on that side. I can't have the square root of negative 5. So no solution. If you were looking at the other one, you would have done 2x plus 3 greater than or equal to 0. Subtract 3 from both sides, divide by 2. So does it even satisfy this requirement? Is negative 4 greater than or equal to, what is this, negative 1.5? No. So all you need to do is find one reason it doesn't work though. Okay? Alright. What else you got? Okay, so here's one of those 2-step process ones I was talking about. So you got 2 radicals that are not like terms. And no matter what you do, when you split these up, so say I decide to add the square root of x to both sides. So you get the square root of x plus 5 equals 1 plus square root x. Okay, so I'm just going to write move 1 square root to other side. So move 1 square root to the other side, then square. A little bit nervous though because I'm squaring a binomial and I'm likely going to not get rid of my square root. Okay, so what happens on the one side, this will be x plus 5. On the other side, you need to FOIL this out, right? So if you want to just visit your notes, I recommend you show your work. So you're doing this, correct? Gotta FOIL it out. So we get 1 times 1 is 1. 1 times square root x is square root x. Square root x times 1 is square root x. Square root x times square root x is x. So group your like terms. You get 2 square root x. 1 plus 2 square root x plus x. So let's see what happens. Let's write that over here. What do you guys think? We had 2 square roots. Now how many do we have? 1. So could we just like regroup and square both sides again? Yeah, you betcha. But it's going to be a long question, so let's get rocking. So, oh, this is nice. I subtract x from this side. I subtract x from this side. And those cancel. Do you guys agree? Yeah? So that's gone. That's gone. So now I got 5 equals 1 plus 2 square root x. I need to isolate this. So I'll subtract 1 from both sides. My square root sides are getting more ridiculous. Should I divide both sides by 2? Yeah. So you get 2 equals square root x. And then we can square both sides again. And you get 4 equals x. Should we verify? Ah, you betcha. So either do your permissible values or verify. Verifying might be easier. So you're just going to show me that, oh, when I plug in 4 plus 5, and then it's what? Subtract square root of x, which is 4. That has to equal 1. So let's see, this is 9. And the square root of that is 3. This is 2. So I have 3 subtract 2 equals 1. So 1 equals 1. Yay! Nice. Work. How are we doing? We're doing good. We got a bit of a longer question too now. One that ends up, we have to factor at the end. I mean, like, we can just keep going. I honestly don't know how many of these you can expect from the test. Like, you'll certainly have some. But you probably won't have every single example we did today. So So we might stay away from this one. I have no idea. I'm not making the test. So. Yeah, I was saying it. Like I could be like, oh, that question's too hard, or I could be like, hey, we should have one of those ones we have to factor.
So none of this will be on the quiz though, right?
On Friday?
Yeah.
It could be. Why wouldn't it be? You have 48 hours.
We just don't do this.
Oh, we gotta do a quiz. Like this unit's massive, right? So
Quiz is 6 months.
yeah.
Yeah,
Yeah, because we sort of did it a bit different. I might add this to the quiz. I might.
Why don't we just do 2 tests? So are you making the quiz longer or are you just conducting?
I might make it a bit longer. Yeah.
Why?
Because we had more time.
like one question.
Jeez, you guys are whiny today. Okay, you guys are giving me a headache. Okay, let's isolate. So let's get one of these on the other side. Can I tell you what I tell my 4-year-old?
What do you tell your 4-year-old?
Nobody likes a whiny baby. Ah, don't whine. So square both sides. Here you're gonna get 4 minus m. And then here, well, you're gonna have to expand it, right? So if you want to do some work off to the side. Oh gosh, this is gonna be horrible. So let's see, we'll get 4 times 4 is 16, and then we're gonna get a negative 4 square root of that, and then we're gonna get another negative 4 square root of that, so we're gonna get negative 8 m plus 6, right? They're like terms, so I just added the coefficients together. And then you got a negative square root times a negative square root that are the same, so you're gonna get plus the radicand. Brutal. So those are like terms, so we're gonna get 22 subtract 8 square root m plus 6 plus m. Is that okay? Yes. Now, on the last question, these two variables cancel. On this question, that ain't gonna happen, right? Because I'm gonna say subtract them, and they only cancel when they're the same sign on opposite sides. So in this case, I'm gonna get 4 minus 2m, and then over here, I'm gonna have, oh boy, 22 minus 8 times the square root of m plus 6. Move this over to the other side, right? We're trying to isolate the square root, so I'll subtract 22 from both sides. So I'll get negative 18, subtract 2m equals negative 8 times the square root of m plus 6. So I quickly check. If I were to divide both sides by 8, does that go evenly into both of those? No. It doesn't. You want to make your life easier, you could divide both sides by negative 1, because then both of these will become positive, right? So you get 18 plus 2m. That'll make your life a bit easier. So I'd recommend doing that. So what are we going to do now? Oh, you could. Yeah. Sure, why not? Let's do it. I like that. I really like that. So what's 18 divided by 2? 9. 2 divided by 2 is just 1, so you get like that. And then here you get 4. I like that you said that because you may not have your calculator. So making things smaller before you're going to go square stuff could be quite advantageous, right? So I really like that you noticed that. So now are we ready to square both sides? We've made the numbers as small as we can. So we'll square this side. That's a binomial, so use a bracket. Now what happens on the right-hand side? So we get 4 squared, which is 16, times whatever the radicand is, because you're squaring the square root, so you get m plus 6. Over here, you got to FOIL it out. So just because it's our notes, maybe we write it over here. So 9 times 9, 81. And then you're going to get a 9m and another 9m, so you get 18m. Start taking that shortcut, m times m squared. There it is. We'll reverse the order, right? We'll write this one first because we like having it that way when it's a trinomial. So we'll go like this. Now what? How do I know I need to factor to solve this? Sorry? Feel louder? Not just the m squared, what else do we need? You factor always when you have the squared variable and
The M.
and the m to the 1, yeah. Very good. So distribute this into the brackets. You're just going to get 60m plus, oh, what's that? 60, is it 96? That would have been a nightmare if we hadn't reduced it beforehand. Right, but 6 times 10 plus 6 times 6, you get 96. Everyone okay with that? Okay. So we're going to subtract this from both sides. So we're going to subtract 16m, and we're going to subtract 96. So let's see, the m squared remains untouched. 18m subtract 16m gives me 2m. 81 subtract 96 gives me negative 15. And what do I have on the right-hand side? Very good, 0. Don't lose your 0. Now can I factor that? I hope so. So it's a regular factoring question. Two numbers that multiply to negative 15 but add up to positive 2. Ah, very good. Positive 5 and negative 3 would work. So then you can use the zero product property, and from this one, oops, you'll get m equal negative 5. And from this one, you'll get m equal 3. Should we verify? Yep, you betcha. What's the original? Oh, there it is. Yeah. Well, we'll do it all. We'll verify. Yeah, and when you verify, like in grade 12, you actually don't need to show your work for verifying. Like, you don't need to show it. Like, you can do it on some scrap paper, do it in your head. All they expect you to do is, if one of these don't work, that you cross it off. And that's understood that, okay, they must have verified and determined it doesn't work. If you cross it off and you're wrong, you'll lose a mark. But so don't just randomly cross stuff off. But let's see, we got 4 subtract negative 5 plus, negative 5 plus 6. That has to equal 4. So this is the square root of 1, which is 1. This is the square root of 9, which is 3. So that one works, right? 3 plus 1 is 4. So that's good. Does the other one work too? Okay, great. I'll take your word for it. In my notes, I have them both working. So.
Well, because it's 4 minus 3 is 1, so it's just 1, and the other one's 9.
Yeah.
Plus 3 is 4.
Exactly. Okay, we got one last example. Just with a cubic root, why not? Everyone good? It's a long lesson, you guys did really well. So, if you got a different index, so for a square root, we square both sides, but if you're getting rid of a different index, what would you do for this one? You'd have to cube both sides. So you cube this side. Oh, by the way, can a cube root equal a negative number? Yes, it certainly can, so that's okay. So then you would get 2a plus 3 equals negative 8. Subtract 3 from both sides. You get negative 11. You get a equals that. You should verify, but we're really short on time. But generally, cubic roots can have negative answers, so you're sort of a little less worried about extraneous roots. With odd indexes, but with an even index, you're always worried, so we should verify b. So what power will I raise that one to? Raise the power of 4 on both sides. So then you'll get the radicand. And then 3 to the 4, anybody know? 81, very good. Just 9 times 9. Or add 3 to both sides, you get 84. So you can check, is the 4th root 84 subtract 3, so 81. Is it equal to 3? This is 3 to the 4, so yeah, it is. It works. Okay. That was long, but we did it. Good job.